Okay, so we are discussing the exponential form. Okay, so basically we've come down to the fact that a complex number can be expressed in three ways. Can be expressed in three forms. These are the three forms. We've already done two of them. This is the a plus bf form, the rectangular form. This is the polar form, also known as the modulus argument form, also called the trigonometric form. And this one is what we call the exponential form. And after we do the exponential form, you realize that the exponential form is very easy to use in multiplication, division, as well as when you raise a complex number to a power. Like raise a complex number to the power 4, to the power 5. If you have the a plus bf form, you will have to do it by the binomial expansion. But if you have the REI theta form, then you just simply apply the power and get the answer. So the R and the theta is the same. The R and theta is the same what you have in the modulus argument form. How do you get the R? You get the R as a square plus b square root. And how do you get the theta? You get the theta through tan inverse b upon a. And according to where the angle falls, you adjust your angle accordingly. So it's the same. So let's say we have a complex number z1 as 2 plus 2i. So clearly z1 mod would be root 8. That's 2 root 2. And the argument of z1 would be pi by 4. Check. Tan inverse 2 upon 2. That's tan inverse 1. So clearly z1 can be written as 2 root 2 e to the power pi by 4i. This is your exponential form. That's it. Let's take another example. Let's say we have another complex number minus root 3 minus I. That's it. So z2 mod I believe is 2, and the argument of z2. Now this is in the fourth quadrant. Check. This is in the fourth quadrant. Minus root 3 minus I. So this is the argument that you will take. You will get this from tan inverse b upon a. So if you do tan inverse b upon a, you will get the basic angle, which is pi by 6. And yeah, so and then you do pi minus. So it's basically pi minus tan inverse 1 by root 3. And whatever answer you get, you know it's a negative angle, so you put a minus sign. So I guess minus pi by 6 is what we should be getting. Minus 5 pi by 6. So tan inverse b upon a actually gives you this one, and then pi minus, and then because it's a clockwise angle, it's negative, so put a minus sign because it's minus 5 pi by 6. So your z2 is 2 e to the power minus 5 pi by 6i. That's your z2. Is everyone okay here? It's the same argument, we're just putting it in a different form. Now see, multiplication and division, everything becomes so easy. Let's say I want to multiply z1 with z2. So forget about the fact that they are complex numbers. Just treat them as just simple numbers. What would you do? This would be 2 root 2 e to the power pi by 4i multiplied by 2 e to the power minus 5 pi by 6i, right? This is what we need to do. How would you just multiply them if you were just simply multiplying these two brackets? You would multiply 2 root 2 by 2. That would have given you a 4 root 2. And then these two indices, you would have multiplied because bases are same, the powers would have been added. You would have done pi by 4 plus minus 5 pi by 6. So pi by 4 minus 5 pi by 6. Can you give me the answer to this?
Minus 7 over 12 pi.
Minus 7 pi by 12. So your answer is e to the power minus 7 pi by 12 pi. That's your answer to the multiplication. Now do you know why we were adding the arguments when we were multiplying the two complex numbers? Now you understand why. Remember when we multiply complex numbers, we add the arguments. This is the reason why. And when we divide, we subtract. So even over here, if I were to divide, we will end up subtracting. See, z1 by z2, let's say. So z1 by z2 would be, z1 is 2 upon z2. Okay, let's just treat them as just numbers. So z1 is 2 root 2 e to the power 5 by 4i divided by 2 e to the power minus 5 pi by 6i. Now how would you divide? You would first cancel out the numbers, you will be left with root 2, and then see, you are dividing the moduli. That's exactly what we did. And then I said subtract the arguments. So upper numerator argument, this goes up. I mean, in this case plus, let's say it's theta, if this is theta 1, this is theta 2, you would do theta 1 minus theta 2. You would make the denominator up, it would become negative, you would subtract. Numerator's power minus the denominator power. This is exactly what we do in division. In this case, it goes up, so see, it becomes 5 by 4 plus 5 pi by 6. Okay, now this is exceeding pi. Your answer for this is coming out to be, how much did you say? 13 pi, which is above pi. The moment the numerator goes more than denominator, you know the angle is gone above pi. So you take the negative counterpart. So the negative counterpart is minus 11 pi by 12. Check, you can check the negative counterpart. This has gone above. This is your 13 pi by 12. We need to take this one. We don't take the argument more than pi. So it's the negative counterpart is minus 11 pi by 12. So this is going to be minus 11 pi by 12 pi. That's your answer. So multiplication division becomes very easy. And there's another thing that becomes very easy in this, and that's when you raise a complex number to a power. Initially, when you were raising it to a power, you had to do the a plus b I whole power. That had to be done in the whole expansion. And especially, expansion bhi ho gayi. What about the fractional powers like square root? You actually have to perform that long procedure for the square root. Remember? You have to equate it to the a plus b I whole square form, and then you have to compare coefficients, and then you were getting a disguised quadratic, and so on. Here, it's just going to be a few steps with the exponential form, and you get your answer. Are we okay till here? Any questions?
Sir, in the power, why can't we have a value above pi? Like the 13 pi over 12?
No, that's just a convention. We don't take the angle above pi. If it's above pi, we take the negative counterpart. That's a convention we follow for complex numbers.
Minus 2, minus 5.
Yeah, it's from minus pi to pi. You can't take a reflex. Okay, let's just see how we can perform the square root. Okay, before I do this one, I just want you to revisit the question that we initially did when we found the square root here, question 5. And we did with the whole lengthy procedure. Let's do this with exponential form now. Let's see if we get the same answer. And in much fewer steps. Let's convert this to the exponential form first. So for that I require the mod and I require the argument. Hmm? 13, yeah. Okay, this is in the fourth quadrant. So your angle is tan inverse B upon A but with a minus sign. So it's minus tan inverse B upon A. Okay, I don't want you to get the decimal answer, just hold on to this. This is the answer. We agree on this? Tan must be upon a, but with a minus sign because it's a negative value. Okay. This is a decimal value, but I don't want to convert to decimals because at the end I am expecting an exact value at the end. So just stick with this. Let me just call this theta. Okay. So the exponential form that we are getting is 13 e to the power theta. Where theta is this angle. You know what theta is. Okay. Now let's say you're interested in finding the square root. You are interested in finding this, which means I would take the exponential form and I would raise it to the power half. Now see, raising this to a power is not a difficult task anymore, you just have to apply the power. So this comes down to root 13, apply the power, half on the 13, and then multiply the power with the power. Powers get multiplied. So this becomes e to the power theta by 2. Is everyone okay with that? By the way, if the a plus bs form is not required, you've gotten your answer. If I were to just write this in the exact form, I can write like this. It's root 13 e to the power minus half tan inverse 12 by 5. This is a complete answer. Because tan was 12 by 5 the exact value नहीं आएगी, so I just wrote this. If the question is okay with the decimal, you can write the decimal there. You've gotten the square root, one square root. You've gotten one square root. But generally what they do is, if they ask you to form the square root, they'll most probably ask you to give it in the a plus b form. So you can convert this easily into the a plus b form now. Square root is done. You just have to convert it back to the form. So to convert it back to the form, you have to do it in just 2 steps. Convert it back to the modulus argument form first, and then the a plus b form. So if I were to write this in the modulus argument form, this would be root 13 cos theta plus I sin theta, right? This would be the modulus argument form, and then this would in turn give you the a plus b form. Now what do you do for the a plus b form? You take the cos of theta multiplied by root 13, you get a. Take the sin theta multiplied by 13, you get the b. So basically, this is your a plus b form. Now, you have the exact value with you of theta. Basically, वो theta by 2 मुझे लिखना चाहिए था. हाँ, theta by 2 हो चुका है ये. Yeah, to be exact, theta by 2. Okay. Can you now just pick up the calculator? Just pick up the. I'll just go with you. I'll tell you. Do it step by step as I say, and you'll get the exact value. Okay. Take the tan inverse of 12 by 5. Please check all your calculators should be in the reading mode. Take tan inverse of 12 by 5 first. Get the answer. Okay. Divided by 2. Get the answer? Put a minus sign there. Minus answer. Got it? Okay. So you got this part done. Take the cos. Take the cos of it. Whatever answer you have, take the cos of it and multiply it by root 30. You will get an exact value. Yes. Got it? Okay, now do the same for the other one. Take the tan inverse 12 by 5, divide it by 2, put a minus sign, take the sine of it and multiply it by root 30. I think we get a minus 2.
Yes, or minus?
Yes. 3 minus 2 which means the square root of 5 minus 12y plus minus is plus minus 3 minus 2y. And this is exactly the answer you got last time when we did it. Are you good? Any questions? Once you get the a plus b form, just be careful of one thing. This plus minus that you put, this plus minus has a validity only with the a plus br form. We don't put a plus minus here. Did you see? I did not put a plus minus here. Just to show you there are two square roots coming out. No. Plus minus has no meaning over here. Until you don't convert to the a plus br form, then you put a plus minus and you get two square roots. One is a 3 minus 2i, the other is a minus 3 plus 2i. Are we good? Okay. Now in the next example I'll tell you why I am not putting a plus minus here. I'll just tell you that. Okay, so is everyone okay till here?
Yes.
Alright. Now let's do this. Now this one I don't want you to get me, let's just get the exact value in the exponential form for the two square roots. So root 3 plus I mod, and I need the argument of root 3 plus I. It's in the first quadrant, so tan inverse B upon A will be the answer. So root 3 plus I can be written as 2 e to the power 5 by 6i. Are you okay with this? Okay. Now we intend to take the square root. So basically,
So why are we taking
because that's the question. Okay, so this becomes root 2 e to the power pi by 6 times half pi by 12i. You have your answer. You have one root. You've gotten one root. You just need to get another one. Now see, plus minus doesn't hold any meaning here. The other root is not a minus root 2 e to the power pi by 12i. Don't write that. If the question wants you to give the answer in exponential form, then this is one root. For the other root, what you need to do is, you need to add a pi to this argument. Why? I'll just tell you. Before we get to the other one, I just want you to realize something which you never realized, because it wasn't expressed this way. What is the square root of 4? Plus minus 2. The plus 2 comes here, minus 2 comes here. They are on opposite sides of the origin and symmetrically distributed around the origin and at an angle of pi. At an angle difference of pi. This is not a coincidence. What is the square root of minus 36? Plus minus 6i? Plus minus 6i. This is 6i, this is minus 6i. They are placed symmetrically around the origin, opposite, with angle difference of pi. Angle difference of pi. Are we good? The two square roots that you got here, 3 minus 2i, one square root is 3 minus 2i, the other is minus 3 plus 2i. 3 minus 2i is here, let's say this is 3. 3 minus 2i is here, minus 3 plus 2i is here. They are exactly symmetrically distributed around the origin with an angle difference of pi degrees. This will always be the case. If whenever one square root stands in the Argand diagram, the other square root has to be exactly 180 degrees on the other end. This will always be the case. So, if this is your one square root, root 2 e to the power pi by 12i, it stands at a position where the angle is pi by 12i, the other square root has to be 180 degree later, or 180 from here, and basically position wahi aayegi. So that means the other square root has to be root 2 e to the power pi by 12 plus pi. Has to be. The other one has to be 180 degree ahead, wherever the first one stands. So pi by 12 plus pi is basically 13 pi by 12, but we don't write that, we will convert it to minus 11 pi by 12, the negative counterpart of it. We just did that. So at the end, your two square roots, I can say plus minus square root of root 3 plus I is a root 2 e to the power pi by 12I and a root 2 e to the power minus 11 pi by 12. These are the two square roots. अब आपकी मर्जी, आपने इसको a plus b फॉर्म में कन्वर्ट करना तो आप कर लो। a plus b फॉर्म में कन्वर्ट करने के लिए you don't have to convert both of them, just convert one of them and put a plus minus outside and you will have your two square roots. And I have mentioned this over here in the notes. If z is equal to r e I theta and you intend to take the plus minus square root of z, then if one root is, when you put it to the power half, this will become root r and e to the power theta will get divided by 2. The other root will be the same but with a theta value plus 5. So I've already stated that over there. Are we all good? Any questions? Alright. So we just had this part. And I held on to this part because the last part can be very easily done with the exponential form. I think we found W. I think W was e by 2 nothing by 2 plus root e by 2r. कुछ था क्या? Check. Was there plus or minus? Plus. Okay, this was it. This was W. That we had found. Okay, now they want us to take the argument of W power n. They want us to raise the W to the power n. Now if you convert this to the exponential form, raising it to the power n is very easy then. And then taking the argument separate would become very easy. So convert this to the exponential form, get the W mod, and also get the argument of W. Is mod W root 3? And is the argument pi by 6? Pi by 6. So W can be written as root 3 e to the power pi by 6. You okay with that? Alright. Now they want us to take the argument of W power n. So W power n would be root 3 e to the power pi by 6 I power n, which would become 3 to the power n by 2, power n half times n by 2, and this would become e to the power n pi by 6. Does everybody agree with me on this? Agreed? Okay. If I ask you, what is the argument of W power n? What is the argument of this complex number? Yes, it's n pi by 6, that's the argument. So the argument of this one is n pi by 6. Okay, I'm just rephrasing this question. Find the least possible integer value. Okay? Okay, so they're saying the argument of this one is greater than 2.5. So does that mean n pi by 6 is greater than 2.5. So this implies n is greater than 4. Okay, which means the smallest possible value of n, integer value of n would be you would have been completely clueless if you would have taken the A plus B form. Any questions?
You should always use this form. You should always use this form.
Okay, my suggestion would be, okay, is everyone okay with this?
Yes.
My suggestion is that if you are adding, subtracting complex numbers, for addition, subtraction, this is a very good form to use. Because addition, subtraction is very easy in this. If you are using multiplication, division, both these forms work equally well. They are both very convenient to use. Especially when you are raising it to a power, this form comes very much in handy. Raising it to a power. Because you can raise a power to this form as well, but it's called the De Moivre's theorem. You don't study that, that's done for that. So we don't need to do that. So when we would be raising a power, we'd rather use this form. Which is less easy. So the question, if they ask you for the square root at the end, and in the question, they won't be specific on the fact that you have to do it by the A plus B form. आपको तो नहीं किया तो कैसे? मगर आपको फॉर्म, आपको प्रोसीजर दोनों आते हैं. ज़्यादातर ये होगा वो आपसे एंड में पूछेगा, give the final answer in the A plus B form. So you can do your entire procedure in the E form and at the end is converted to the A plus B form. Are we all good? So complex numbers.